All right. Hello and welcome back. So this time we're going to talk about the 10 rules of simplifying and Boolean expression. In this video, I will briefly go over the intuition uh, behind each of the 10 laws, and then I'll show you an example of applying these. Okay. So as for the identity law, we know that true and anything is whatever that thing is. True and true is true, true and false is false. And in the or form, the identity says um, false or anything is that, anything. So false or false is false, false or true is true. The null law, it basically says how can we eliminate one variable. So false and anything is always false, and true or anything is always true, as we've seen in the null rule. Moving on to the idempotent law, I'm not sure I'm pronouncing that correctly, but basically A and A is always A or A is always A also. So true and true is true, false and false is false, true and true or true is true, false or false is false. Moving on to the inverse, this basically tells us how variables uh, interact when they're connected with their complement. So A and not A is always going to be false because there is no case where both can be true. A or not A is always true because there isn't a case where both of them are false, because they're always the opposite of each other. Moving on to the commutative law, this is similar to what we have in real number arithmetics and algebra. A and B is the same as B and A or B is the same as B or A. Pretty intuitive. And the same goes for the associative laws. They're similar to real number algebra as well. A and B and C is the same as A and B and C. A or B or C is the same as A or B or C. And moving on to the a bit more difficult laws, which is the distributive and absorption laws. For the and form, basically, try imagining a truth table in your head. So the left-hand side says A or B and C. This is true when A is true or B and C are both true. And in the right-hand side of the equation, we have A or B and A or C. On the left-hand side of the and, um, it would be true when A is true or B is true. On the right-hand side, we have if A is true or B is true. If A is true, both sides are satisfied. And if A is false, the only thing that makes this expression true is when B and C are both true. And moving on to the or form, it's a bit more intuitive. A and B or C is true when both A and one of B or C is true, which is kind of the exact same thing on the right hand side of the equation. Uh, it would be true when either A and B or A and C is true. So if so basically we have the right hand side being true when A and B is true or A and C is true, which is the same as saying A is true and one of B and C is true. Moving on to the absorption law, A and A or B is just A, because if A is true, the right hand side of the and is immediately satisfied, and then we have no reason to look at B. And if A is false, the left hand side of the and is immediately falsified, and the expression will ultimately become false. And once again, we have no reason to look at B. So B is eliminated. And in the or form, A or A and B is true when either A is true or A and B is true. If A is true, the right hand side of the or which is A at B is immediately true, giving us no reason to look at B. If A is false, the right hand side of the expression, which is A at B, is also immediately falsified, therefore giving us no reason to look at B, therefore B is effectively absorbed. And then De Morgan's law. It's a bit more intuitive in the sense that you kind of speak in the way of De Morgan's law. Basically, not A or B is the exact same thing as not A and not B. I can't really come up with a good sentence right now, but you can probably come up with something good. Oh, I have one. I'm not a high school student or a primary school student, which is effectively the same as I'm not a high school student and I'm not a primary school student. The same thing kind of goes for the or form. Not A and B is the same thing as not A or not B. You can come up with a sentence similar in that fashion as well. I'm not going to give you an example. And the double complement rule, which is one of the even more intuitive ones. Basically says not A, it's just A, because when you negate something twice, it's you get back what it originally was. So let's look at this example. Okay, sorry about that. So let's get started. So what can we do? Let's try expanding first using the associative, no, the distributive law. So this gives us A and B plus or B and not C or A, or using the distributive law again, we get A and not A or A and B. First thing to notice is that this term, by using the inverse law, we get false immediately. And the second thing to notice is that these two terms are the exact same, meaning using the identity, not the identity, sorry, the idempotent rule, one of them can be just eliminated. And note that since this is zero or anything is whatever that anything is, so the zero just is gone, right? So by simplifying this, we get A and B, or B and not C, or A, and that's it. And then moving on, we can use the reverse version of the distributive law. And wait, actually, yeah, the reverse version of the distributive law, we can get something like A or A and A or B using these two terms, or B not C. And using the idempotent law, this term is just A. I'm just writing it down again. And then using the absorption law as in the and form, we know that, sorry about that, we know that this term is the exact same as just A. So in the end, we get A or B and not C. As you can see here, we simplified down a very complex Boolean expression to a relative simpler Boolean expression. And that's kind of the power of limiting the number of variables, which we didn't really do much. We still have A, B, and C, three variables, but we can see a dramatic decrease in the number of logical gates or logical connectives or logical operations that we ended up using. Okay, there are a ton of other exercises I recommend you doing on your own. Your teacher will probably show you the answers in class, or you can ask her for the answers. And let me know if you have any questions or doubts in the comments or in any way you prefer, and have a great day.